In this video, we will see dry run of the code.
Okay, now let's see a quick dry run of this. So here we have the elements and here we have the indexes. Okay, so these are my indexes and I have taken one array. This is my array and here n is equals to 5 and let's see how our code works. So I will start from I, that is at 0. So I am putting I is equals to 0. I am taking one minimum. All right. So my minimum will be at I, that is minimum will also be 0 and I will start from j is equals to I plus 1 till n. So I will start from I plus 1, that is 0 plus 1, 1. So basically what we are doing here, that is a bit different from the previous one. So here I am assuming that my 9 is the minimum element, right? So I am just checking the rest of the element. Is there anyone that is less than 9? And then I will update it, right? This is how we are doing the minimum. Okay. In the previous attempt, we simply started from 0 and we will move to the last value 4 and we check the minimum. That's why the iteration there in the last, we said it n. But when we are starting from here, the iterations will be n minus 1, not n, because we are assuming 9 is already minimum. Similarly, when we start from here, the iterations will be n minus 2 here. Again, the same time complexity will be again same big of n square. Only the bit uh, difference will be, it will be n square minus n by 2 by these like logic. It will start from n, n minus 1, n minus 2, n minus 3 and so on. Right. But still the time complexity will be big of n square. I just need to remember you like suppose if you want to explain this thing to someone else. Okay, so let's quickly start. I started with this. I am checking is my jth element and my minimum element, right? So 9 and 7. Is 7 is less than 9? Yes, it is. So I will assign minimum is equals to j. So I will assign minimum is equals to 1, right? And I will do j plus plus. I will move my j pointer. So now what is my minimum element? 7 is my minimum element, right? Is 4 is less than 7? Yes, it is. So I will assign the position of 4, that is to my minimum, and I will move my j pointer. Then I will check is 0 is less than 4. Second element, yes, 0 is less than 4. So again I will update it with the position of 0, that is 3, right? And again I will move is 2 is less than 0. No, it is not. So we won't come under this if condition and we will simply move it, right? And this is the last element, right? Last iteration, because I check the last element and we will come here and we will swap I and minimum. So I will swap this I with my minimum, right? So I will swap 9 with 0. So after swapping 9 will come here and 0 will come here and the rest of the elements will be same here, right? You can check it. Now what will happen? I will be moved to I plus 1 because can I say my zeroth element, like my first element is sorted, right? So this is now sorted. Okay. So what I will do? I will move my I pointer. Again, we'll start with minimum is equals to I. So my minimum is will be 1. And again, I will start from my jth pointer. So j pointer again start with I plus 1. So j will start from here, right? Now I will check. Is 4 is less than 7? Yes, it is. So I will update the minimum position with 2. Minimum is equals to j. Then I will move forward. Is 9 is less than 7? No, it is not. I will simply move it. I won't come under if condition. I will check. Is 2 is less than the minimum position? That is 7, right? So yes, like that is 4. Okay, that is so yes, I will say yes, it is less. So what I will do, I will at the position of minimum here, so that is 4. Now what I will do again after this, once this loop end, right, we will come to this condition swap I and minimum, right? So what is I is at 1. What is minimum? Minimum is at 4, right? So this is 2. So what we will do, we will swap these two elements, right? So after swapping, okay, 0 was already there. My 2 will come here, right? And 7 will come here and the rest of the elements will be same. So my rest of the elements will be same. And now after this, we will do I plus plus. So now I will be at this position, right? Again, we will start my minimum. So minimum again start with the position number 2 now with the I. and we will use j point. J will be I plus 1, so j will start from here. Again, I will check, is 9 is less than 4? No, it is not. Is 7 is less than 4? No, it is not. Right? So there is no update in minimum. Right? So I will come again under this condition, swap I and minimum. So both I and minimum pointing to the same element. So swapping won't change anything. Right? I is also at 2, minimum is also at 2. Right? So swapping won't change anything. So this will also swap. And now can I say my three elements are now sorted, right? This was also sorted. My three elements are sorted. Only the left elements are 9 and 7. My I pointer will be here, and my j pointer will start from I plus 1, and my minimum is also pointing to 3. I will check, is 7 is less than 9? Yes, it is. So what I will do, I will update my minimum. I will update my minimum is equals to j. And once this loop end, because that was the last iteration, its loop end, it will come under here, swap I and minimum. So I is pointing to 3, minimum is pointing to 4. So we will swap 7 and 9. So we will swap 7 and 9. And can I say my now 4 elements are sorted? Okay, 0, 2, 4, 7, right? Now only one element left in the unsorted part. But since one element is left in the unsorted part, can I say my whole array is sorted now? Yes. So we can say my whole array is now sorted. And how many passes we have done? So this, if you count with this one, so here you have done one pass. Okay, second, third, and fourth. In the fourth, you got the result. So again, total number of passes or number of steps will be n minus 1, right? And how our loop is working? So basically, when I is at 0, my j is starting from 1 to n minus 1, or you can say the last element, right? When I is 1, j is starting from 2 to n minus 1, last element. Okay, you can say n or n minus 1. Okay, it's up to you. Basically, less than n and equals to n minus 1. Then when I is 2, j is starting from 3 to n minus 1, right? So if I am counting the first here, how many like number of iterations will be n minus 1 in I is equals to 1. Like this will be the same case. Let me just put it. So this will go till I equals to 4. J will start with 5, and that is till 5 only. Okay. So if I simply put it here, n minus 1, this one, iterations, plus n minus 2, plus n minus 3, and so on, it will be 3 plus 2 plus 1, right? It will become n minus 1 by 2, that is n square minus n by 2. So if I am ignoring the constant, taking the higher order degree, so it will be big of n square. That will be time complexity of your code. So again here the time complexity is big O of n square, and the space complexity is big O of 1, because you are simply adding all the elements in the same array, right? You are not taking any extra space. So yes, this is how your bubble sort works, and these are all questions that can be asked here, right? They can also ask now what will be number of swaps. So you can also mention, like, if the array is in completely descending order, right? Array is completely descending order, still the swap will be here only 1. Okay. Why I'm saying 1? Because we are updating minimum is equals to j, but we are doing swapping only one time. Right. So you can see here I basically selected my lowest element, that was 0, and I have done the swapping only one time. Right. So swap that is happening during a pass, that is only one time. Okay. Not by bubble sort where we were doing n minus 1 time. So that's clear. I guess now you can quickly apply selection sort anywhere. Now you can also apply bubble sort anywhere. You are good to go with it. And I hope you like the code dry run, and everything is all set. You are ready to apply these sorting algorithms. Thank you.